Okay, this is the P4 paper from October 2021. It's question number 5, which is a differentiation question. In fact, it's a parametric differentiation question. Let's have a look at it and get started. So it says the figure, the picture there, shows a sketch of the curve x equals 5 plus 2 tan t, and then y equals 8 sec squared t, and that's between values for t from minus pi over 3 to pi over 4. And first part says, can we find the gradients of c at x equals 3? Yeah, well, we can absolutely do that. Let's make a start then. So for part A, we've got that y is equal to 8 sec squared t. If I want to get the gradient, I want dy by dx. And if I want to get dy by dx, I need to find dy by dt, and in a minute dx by dt. So differentiating 8 sec squared, if you think about it as something squared, differential of something squared, multiply by the power, take one off the power, gives me that. But this is a function of a function, this is a chain rule question here, multiplied by the differential of sec, and the differential of sec is sec t tan t. Obviously, if you have problems with those, you're going to need to do a little bit more work on your basic revision of differentiation. Tidying that all up is going to give me 16 sec squared t tan t, and I'll worry about making that tidy a little bit later on. Let's work out what the x is going to give us. We've got x equals 5 plus 2 tan t. So dx by dt, differentiating this then, the differential of tan is sec squared, so that's going to give us 2 sec squared t, and then I want the gradient, so I want dy by dx, and dy by dx is going to be dy by dt times dt by dx, so dy by dt is 16 sec squared tan, and dt by dx is 1 over dx dt, so it's 1 over 2 sec squared t there, then that's helpful. That's going to cancel. That actually gives me, relatively straightforward, 8 tan t for dy by dx. So at x equals 3, well, let's go back and remind ourselves what x is. X is that thing. So at x equals 3, I get that 5 plus 2 tan t is equal to 3, which in other words gives me 2 tan t equals minus 2, tan t equals minus 1. So dy by dx then is going to be 8, lots of minus 1. That's all been designed very nicely, hasn't it, to give me a value of minus 8. So just go back and check the question. Said find the gradient at x equals 3, and we've done exactly that then. We've found the gradient at x equals 3. Part B says, can we get our function, can we get our y equals fx for our function? So can we change this from a parametric one into a Cartesian one? Lots of different ways of doing these. What I first of all do is I go and look at my two parametric versions. I've got tan and sec squared there, and I think, is there a trigonometric identity that I know that connects those? And of course there is. 1 plus tan squared is sec squared. So if I can get tan equals from that and sec equals from that, or rather sec squared equals from that, then I can just plug those into my identity later on. So part B, I'm going to start off with x is equal to 5 plus 2 tan t. And from that say, okay, I'm going to rearrange and get tan equals. So x minus 5 equals 2 tan t. So tan t is x minus 5 all over 2. And the whole point about doing that is I'm going to do 1 plus tan squared is equal to sec squared. From the other one, I've got that y is equal to 8 sec squared t, so straight away I can get sec squared then. So sec squared is equal to y over 8. And now these two things here, I'm going to plug into. So we know that 1 plus tan squared is equal to sec squared, and now we can just chuck in everything. So 1 plus, in this case, x minus 5 over 2 squared is equal to y over 8. Let's just make that handwriting a bit neater for x minus 5. So that's the answer, but we've got to write it in the form y equals. So, I mean, there is my Cartesian equation, but they've said, can we have it in the form, what do they want? Y equals, let's have a look. Y equals a x plus b all squared plus c. Yeah, well, we can absolutely do that. So if I'm going to do that, that's 1 plus x minus 5 squared over 4 is equal to y over 8. I've just simplified that bracket out a little bit there. And now what I'm going to do is multiply everything by 8. So I'll get 8. I'll get 2 lots of that is equal to y. Oh, that's done. Okay, well, I was expecting it to be a bit more complicated than that. Y equals 2 bracket x minus 5 squared plus 8. So yeah, I didn't have to multiply it all out and then tidy it up later on. We've got straight to our answer for part B. So part B, written down like that, you should identify that straight away. That's what we sometimes do when we complete the square to work out maximum and minimum values. And if we want the range of f now for part C, the range of f is going to be from there, not to here. Be careful. If you put those two values in, you're likely to get those two answers. But our range is, yes, it's that top one, but it's down to this bottom value here. There's our range. Our range is going to be whatever those values are there. So first of all, I'm going to focus on working out the minimum because we've got that pretty much already done, and then we'll have a look at the maximum. So part C, trying to find the range. So, excuse me, if y is equal to 2x minus 5 squared plus 8, then anybody who's done any work on completing the square, can we say straight away, we know the minimum value is that then, and it's going to occur when x equals 5. Minimum point is 5, 8. The smallest value that x minus 5 all squared can be 0. Okay, and that occurs when x equals 5. So 2 lots of 0 plus 8. Anything else, you'll have some value there, and any value there is going to make it bigger than 8. So our minimum point is 5, 8. And out of that, we're actually interested in the fact that y is equal to 8 there. If we want to work out the maximum value, we've got t was from pi over 4 to minus pi over 3, and one of those is going to give me this n value here. One of them is going to give me this n value here. So we don't know which one it is. You can just substitute both of them. It's worth 2 marks, so just a quick, rather than trying to do anything clever, you probably could work it out. But y max is 8 sec squared t. So it's either 8 sec squared pi over 4, or it's 8 sec squared minus pi over 3. And actually it's that one that gives us the smaller value. So 8 sec squared minus pi over 3 works out to be 8 lots of 4, which works out to be 32. So my range of values then for fx is between 32 and 8, and let's just look at those limits again, including the equals part. So that's the range of values for that question. Okay, hopefully that all makes sense to you.